to do is we're going to actually see that when we use the completing the squared method, the completing the squared method actually helps us find the axis of symmetry in the vertex really quickly. It's going to help us find the axis of symmetry in the vertex really quickly. So when we have a quadratic in this form, the completed squared form, so here, this is the completed squared form that I was talking about. What it tells me is that x is equal to h, so this h value is going to be my axis of symmetry. So my axis of symmetry is that x is equal to h. But not only that, this k value at the end is also really important because it will tell me where the vertex is. It will actually tell me that the vertex is at h, k. It's going to be at h, k. And this is really important because this is that final step in that 5-step method of graphing a quadratic that we used last time. We can actually, by completing the square, we can actually quickly find the vertex and the axis of symmetry without having to do any additional substituting and additional steps that we did last time. So when we're actually graphing our quadratic, we can find the axis of symmetry and the vertex really quickly. Now you might be wondering, we need to also find the X-Intercepts. And so this is where it comes into, this next part comes into play. So when we're trying to find the axis of symmetry, not the axis of symmetry, the X-Intercepts, what we need to do is then we complete the square and then we substitute y is equal to 0. We were doing that last lesson already. Now, there's a few cases where that will happen if we were to do this. There's a few cases that might happen. So the first case is there might be 2 zeros like we did last lesson. So if you notice, so this case is if I had 2 zeros, if I drew up my quadratic, I have 2 points where it crosses the x-axis. So for example, this point over here, I'll do it in red so we see it, and this point over here. That's the first case. The second case is there might not actually be any zeros. Sometimes your vertex is either above or below the x-axis, and the rest of the parabola is also there with it. So there's going to be cases sometimes when there's no zeros, and it looks something like this. They either are fully above the x-axis, so something like this, or they're fully below the x-axis. And so there aren't actually going to be any x-intercepts. If you have a look along my x-axis, there's no points that these two parabolas touch my x-axis. And there's also a final case where there's only 1 zero, and this is called a perfect square, and this is the case where there's a double zero. So what this looks like is, if I drew my parabola, it touches the x-axis at one point only. So here, this is the case of a perfect square. And so by completing the square, you're going to need to be able to find the x-intercepts by doing this main step of solving y is equal to 0. And we're going to go through a few examples of that down below. So let's do a first example here. The first example I have, I want to sketch f of x is equal to x squared minus 4x minus 1. Okay, now when I'm doing this, maybe I'll make a note here. When I'm doing this, the 5 steps that we did previously, the first 2 are going to stay the same. I'm still going to check the concavity. I want to see which way it goes. Is it a face up, concave up or down? So is it facing upwards or is it facing downwards? I still want to check that. The second step, the Y-intercept, I still want to check that. I want to sub in x is equal to 0 to find the Y-intercept. I'm still going to do that. But unlike solving it by graphing the parabola by solving, factorizing it, what I'm going to do here is I'm going to complete the square, and this will find me the vertex and the axis of symmetry quite quickly. And once I've done that, I'm actually not going to need a step 5 because then I'm going to just check for x-intercepts. And this is by substituting y is equal to 0. So when we're graphing a parabola by using completing the square method, these are the 4 steps I'm going to actually end up using. So let's have a go at this first example. We want to sketch f of x is equal to x squared minus 4x minus 1. So let's have a go at that. Here it's already the coefficient of x. Oh, actually, Start from the very beginning. Step 1, we want to check concavity. So if you remember, when we check concavity, we look at the coefficient of x. So the coefficient of x is equal to 1, and so therefore, our graph is concave up. Because 1 is a positive value, it's going to be concave up. It's going to be a nice little happy face. Okay, step 2, I'm still going to find the y-intercept. So I want to sub x is equal to 0 into my graph, into my function. So here I'm going to have f of 0 is equal to 0 minus 1. So f of 0 is equal to negative 1. My y-intercept is equal to negative 1. Okay, now that I've done that, I'm going to do step 3 of my completing the square method, where I'm actually going to complete the square. So if you ever look, what I need to do when I'm completing the squares, I'll look at the x coefficient. And so here it's going to be negative 4. I'm going to halve it and then square the result. So here I'm going to have negative 4 over 2, which is negative 2. I'm squaring that, which gives me 4. And so what I'm going to do, I'm going to do that method of completing the square. So here I'm going to have f of x is equal to x squared minus 4x. I'm going to add and subtract that 4 that I found up here. So I'm going to add it right after that 4x. But because I'm adding it, I also need to subtract it from my function. Then at the end, I still got that minus 1. What do we do after that? Well, I'm going to group my first 3 terms together because that is a perfect square. So I'm just going to rewrite that as x minus 2 all squared using that perfect square factorization. Okay, cool. Once I've got that, I've also got the numbers at the end, and that gives me minus 5. So immediately from there, what can we tell? Well, we can tell that the vertex is actually going to be, so it's going to be this 2 minus 5. So my vertex is going to be at negative 2 minus 5. So just remember, if we have our completed square, x minus h all squared plus k, the vertex is at hk. So just be careful, it has to be x minus h here, and it's just the whatever value of k at the end. So I have my vertex to negative 5. Okay, cool. So I've got the vertex, I've got my concavity, I've got my y-intercept. The final part I'm going to check is I'm going to find my x-intercepts. So x-intercepts, if you remember, we substitute y is equal to 0. Now I've got my function in my completed square form, I'm going to just go, okay, f of x is equal to 0. So I've got x minus 2 all squared minus 5 is equal to 0. If I'm solving this, I'm just going to move this negative 5 to the other side. When I move it to the other side, it becomes a positive 5. So I have x minus 2 all squared is equal to 5. And when I take the square root of this, because I've got a perfect square here, when I take the square root, I need to consider the positive and the negative case. We wrote this using a symbol plus or minus. So here, I'm going to have x minus 2 is equal to plus or minus square root 5. I'm going to take the square root of both sides, and I need to consider the positive and negative cases of both of that, of here. So to solve it, I'm just going to have x is equal to 2 plus or minus root 5. Now what you need to check sometimes is the value of that, these two numbers. So what I'm going to do is I'm going to put it into my calculator. So I'm going to do 2 plus square root 5. The reason why I'm doing this is I want to just get a general estimate of where that is. So 2 plus square root 5 is going to be roughly 4. So that when I'm graphing it, I know roughly where those numbers are. Because I'm not sure about you, but I intuitively can't tell what 2 plus square root 5 is. It's just quite difficult to see. I'm going to do the same thing for 2 minus negative 5. So I'm going to do 2 minus negative 5. And that'll give me, so that is approximately negative 0.5. Somewhere around there. Okay, now that I've done that, I'm going to graph my parabola using all of this information that I have here. Okay, so I'm going to draw up my axes. Now I know that my two roots are at 4 and negative 0.5, so I'm going to go somewhere like this. Okay, like that. Y, X. Okay, so I'm going to start from the top. My concave up graph means it's going to look something like this, smiley face. Then I've got my y-intercept at -1. Step 3, I've got my completed the square, so I've got my vertex is going to be at 2, -5. I'm going to put it somewhere around here, so I've got 2, -5. I've got a point down here. And then once I've got that, I've also got my 2 X-intercepts. So I've got my X-intercept at 2 minus square root 5 over here. And also 2 plus square root 5 somewhere over here. And so once I've got all that information, I'm going to put it all together. So my graph is going to look something like this. It's going to go down. It's going to go through 2 minus square root 5, through my y-intercept, through my vertex, and then all the way back up, and through 2 plus square root 5. And so here we've got f of x is equal to x squared minus 4x minus 1. So there we go. That's how we use completing the square to graph a parabola.